Yeah, so today we are going to talk about the how we can identify the workloads. So there are few different ways by which we can do it, which we are going to look at now. So yeah, you can watch the recording for the previous two sessions. Let's go with the next here. So um, so now we're going to cover service account tokens, which I think most of you would have used or at least heard about. What are these? What are service accounts and what are they being used for? But at a high level, basically these are the primitives in Kubernetes that provides identity for group of pods. So as you know that when we create a pod, every pod basically get attached with a default service account. So now, why do we require that? So in a very simple terms, let's say if you are running an application and that application need to communicate with the API server or with some other applications, how it can authenticate and then connect. So think about an example of your dashboard application of Kubernetes. You have a dashboard app, which is uh, you may have written in Java or Python, whatever language. But then that dashboard app to work, it need to connect to the API server, correct? Only then it can kind of get the right objects and so on. So now, how does that dashboard app connect to the API server? That is where we can use service accounts to kind of do that, right? So that is there. So now think about, or you can also think them about as a user for your applications. That's a terminology which I use. So your applications user, you can refer them as service account, and for each one of those users, there is a respective secret attached to it. Secret is a password, right? So basically, when you create a user, you create a password for it, and with that password, it can connect to the API server. Now, of course, things have changed, but just keep in mind this book was written, I think, when it was 113, 114, so it is a bit old book, but things have been changing over the years. But I'm looking at the context of this book, and then we know that now the secret does not come by default. But yeah, I hope you understand that, right? So currently the context is with the book, and then we'll try to look at how things are happening right now. Just allow me, my throat is not so good this week, so yeah. Um, Yeah, so again, the next part, what was mentioned here is, of course, uh, you create these users or you have a source account using which you can only perform the authentication, which means by this you can log into the given app or the API server, what you have there. But to perform the different operations, you would still need to authorization. So you still need to do authorization there. Just give me a minute. Just get this here. Yeah. So sorry. Correct. That is the point which is mentioned here. That do you create the user? So this is what a simple source account kind looks like. So if you look at the source account kind, you will see that there is a default. So whenever we create a namespace, automatically our service account for that namespace gets created, and it also have a password attached to it by default, again with the perspective of the 1 point whatever the version of this book was, right? And then we can look at the given secret if we kind of look at the description of this particular secret, right? So we can find out what are the token given to it. So that is how it is. And now, of course, by default, when we create a pod, so what happens is when you have a namespace, automatically serves account with the name of default gets created. That's point number one. Point number two is when you create a pod, automatically the source account get attached to it. So by default, the default source account would be attached to the pod which you are creating in a given namespace. But of course, you can configure to be disabled. So basically, you can say that don't attach the default source account to my pods as well. So that you can configure. Or you can choose to have a custom source account which you can attach to a given pod. So like in this case, we are saying that create the pod called my pod, but don't attach the default one, attach what we are giving here. So that is how we attach source account to our pods. Any point somebody want to mention here? Anything you want to add here? Anyone? Okay, great. So okay, so the next, I'll come to this particular report later. Let me show the image first here. So, what was mentioned here, I think there is one more point which I want to highlight. Hmm. So, this is the point which is pretty important to understand. Yeah. We can look at this particular article, the message, the para here. Source accounts are the way that Kubernetes itself usually authenticates in cluster access to the API. This is what I mentioned earlier, right? That the application like dashboard want to talk to the API server and they will communicate with this. Okay, fine. So now this is how the flow would look like. So now there are three actors here. If you want to kind of picturize that, one is your pod, then your server application. This can be again you can think of as your API server itself or some other application, and then you have this Kubernetes API server here. So now the pod, which is having the source account, sends a request to the server application. Now, if this application need to kind of verify whether this particular pod is the right or is valid to authenticate with the API server, or I can trust it, right, in a way. So what it does is whatever the token is being shared from the pod to the server application, it would call the token review request to the API server, and then API server would respond back. And if whatever, depending on if it pass or fail, of course, it would pass in the current scenario. It would then give the response back to the pod, and then we communicate like that. That is what has been mentioned here in this particular context here. So what is happening here is this is a curl request. So the destination app can verify the provided token by calling the Kubernetes token review API. So so the destination app, whichever it can be, it would basically first of all provides its token. So this token is for the destination app to authenticate with the API server, and then it is kind of giving the second token to be verified by the API server. So this is the token. The second number token is given by or of this particular pod through which the communication is being set up. Um, Anything anybody wants to add here? Okay. Sorry. Now, do you see any challenges here? What challenges can come here in this kind of scenario? Guys, anything you think of? What is the challenge here? What can be the issue? So one other issue which I can see here, once the token is being given, there is no kind of TTL, right? How long this token would be valid for, right? So if the token is there, and if you don't have a time to live, then this token can be misused. That is one challenge what we can see here. And of course, these tokens are scoped for a single cluster. We cannot um, take this and authenticate with other cluster, right? So that is something which is there. Any other point here? 1 minute. Okay, so that is what is being kind of mentioned here, that such accounts here. Then we have the next is projected such account tokens. So this is like kind of a better version of the previous implementation. So what happens with this is the challenge of the TTL is kind of taken into account. So basically, now we can specify that a given token would be valid only for a given time frame, and that is what is being handled here. Now, the way it is being handled is by configuring the projected volumes. So, if you know what is this volume, right? With this volume, what can happen is we can take a mount location, and in that mount location, we can mount multiple endpoints or multiple objects, for example, secrets, then your tokens, then your config maps, and so on. They all can reside under a given location. So rather than having the such accounts which by default um, kind of get copied. So one thing which I did not cover, but I thought you may be aware of it already, that when you create such accounts and when you mount the such account into a pod, automatically at a given location, which is I think somewhere where runs such accounts, it would be mounted. Let me just see if I can find that here. Hmm. Yeah, something here. Yeah, correct. This location. So this is where the token would be mounted from a SUS account perspective, right? So you mount SUS account into a pod, and whatever the secret is being given, it is mounting under this location, and from there it can send the request to the API server and authenticate, and all that stuff can happen there. So that is there. So rather than doing that mount, what we are doing in this case is projected mount here. That is the main kind of a thing to understand here. Now, as we are mounting as a volume, what we can do is we can provide additional parameters, and one of it is expiration seconds. So after a given time frame, the given token, whatever is there, it would be expired, and it can be refreshed as well. So that is what I recall. So that way, given token is not valid after a for a I mean for a long period of time, but only for whatever time has been configured here. So that is what the PSAT is. And one thing what is mentioned here, which I was not too clear about it per se, there is this audience part being configured here. So to use this PSAT, you need to kind of give this audience part into your API server, and that you have to use as you are using the volumes. So what I got for the kind of the explanation for that is this is required because it should not happen that somebody else comes and kind of um, project or kind of mimic themselves as a kind of just let me get this point 1 minute. Hmm. Yeah, it is here. Yeah, the audience field is important as it identifies the intended recipient of the token. Okay, so it makes sure that it is meant for the given endpoint only, not for anybody else. So, for example, um, in this case, meant for the API server, because when we are kind of, again, the flow looks same as you can see here, right? And then the flow is similar to the last one, but what's happening additional field here is it identifies that it's for the given API, whatever was mentioned there, and that audience, and based on that, it would further communicate. So that is what I could make out of this. But if anybody has better explanation of this, please do share. I'm really sorry. Sorry, my throat is too bad. Yeah, sorry guys. Anybody wants to add anything else more on this? Okay, great. So the next part, what has been covered in this book is how do you take care of identifying your nodes, right? So when you communicate between the applications, um, how do you make sure that they are coming from the right nodes, or in a simple terms, if they are coming from the right pod itself as well, right? So how do you kind of verify that? So one way of doing it is if they are on the same environment. So for example, if all of these apps are running on AWS, apps in a way that think about your entire cluster is on AWS, like for the EKS cluster, right? Now, as they are all on AWS by themselves, they would have some kind of identity by themselves, right? For example, AWS can identify that this is, or this particular instance is part of my environment and I can trust it, right? So if that level of trust can come from your platform itself, then things can become much more simpler as we deploy our applications, right? That is the whole point of this particular part, chapter, this particular section of the book. That if you can trust your nodes, things can become much more simpler. Um, yeah, so what happens is the platform by itself identifies the respective workloads, and so the platform itself will determine and assign identities to workloads because of the contextual meta information what they have about the workloads, right? So what is mentioned here, let's say if I'm on AWS, I can trust the backend front end app because they are all running on the same environment. And the thing which was mentioned here is they kind of assume that it is done on the EC2 instance as a starting point. So in the case of EC2 instances, it is much more simpler. But now, as we are kind of going towards pods and containers and so on, you need something more on top of it, correct? Because you can't just basically uh, based on the nodes, you can't kind of make all of your assumptions and do that. And that is what the next point was is mentioned here, that we want to kind of do something more when we are using Kubernetes or containers in general on top of the EC2 instance what we have, correct? So in a nutshell, what we want to kind of attach is we want to give some kind of uh, identity to our pods so that they can go and connect to the AWS other applications. So think about you are running a pod in your cluster, and now you want to access the S3. Now, how do you make sure that that pod is able to communicate with the S3 seamlessly? Oh, we can only do that if we can identify um, our pod's identity in a way that AWS can verify that, correct? So that is what has been mentioned here. So there are a few different ways by which it can be done. One of the way it can be done is with the help of Cube2 IAM. So as we know that IAM is nothing but identity management of AWS. So what is happening here is um, we kind of deploy a Kube2 IAM agent on every node. Then we have a pod running in our, of course, cluster. Now, this particular agent, what we have, can communicate to the AWS and request different kind of request, let's say S3 other stuff there, right? So what we're doing here is Kube2IAM requires that every node in the cluster is able to assume a superset of all the roles that pod may require. Now, look at here. What does mean superset? That is the thing to kind of worry about. So now think about there are multiple pods, and now one pod only access only want to communicate with S3. Now let's say other pod want to communicate with other services of AWS. Now, how do you basically differentiate? We can't differentiate them right now with the help of Cube2 IAM, because this Cube2 IAM would have all the roles which are required by all the pods in a given node, correct? Which can be basically a bit challenging, because if one pod has an issue, then it can actually affect the entire environment, because it would get the permission which was not supposed to be given for the given pod. Hope it makes sense, right? So that is what the Cube2 IAM is, that you are putting the agent on every node, and then not yeah, every node, and then in a given pod, when you're deploying a pod, you specify what role you want to give for that particular pod, and it would communicate via this agent. So though you specify your role here, but Cube2 IAM would basically communicate with AWS and then get your work done. So anybody has used Cube2 IAM earlier?
No.
And I have a question. Is Cube2IAM is very specific to AWS or
Yes, yes, it is.
okay?
So the similar would be there for other cloud, but this book has given the example of AWS only.
Okay, okay, okay. Thank you, thank you.
Okay, so better version of this is the next thing, which is KIAM. So now, rather than giving the superset to the individual node, what happens in this case is we are running this KIM server somewhere outside of the nodes, some specific node per se, and then all of these nodes have this agent running. So now you are not giving the superset permission to the this agent, but you specify only from the pod perspective what I need, and this agent would eventually communicate with this KIM server and then talk to the AWS. So it is better than the previous case. But the challenge what is being mentioned here in this case is again, this is a flow. If you can see that, right? So pod request a role. Agent would take the request, again the same request to the KIM server, and then if it is kind of verified or it's been kind of authenticated, it would come back given to the pod, and then pod can communicate to the S3. So this is how the flow would look like, right? So that is what is being mentioned here. So this is better than the previous one. But the challenge here is what can happen is what if somebody runs a pod and deploys that pod on the node B? Are you getting my point? So this particular node may have permissions, and if your pod get deployed on this machine, then it can basically take the um, much more privileged role in this case, right? So what we have to do is we have to kind of make sure that none of the pods get deployed on this particular node, and that for that purpose we can use some kind of admission webhooks to make sure that that has not been set up beforehand. So that is what I could understand from this. Um, does it make sense? Or uh, again, guys, I may be wrong. So yeah, I mean, just make sure that you correct me if I'm wrong anywhere. Um, okay, just trying to get my notes for the next part of the chapter here. One minute. This is something which I'm not too sure. Okay. Yeah. So, what is mentioned here is, or what I could get from here is, rather than now kind of going to have an agent and all those things, what if we can kind of give um, those roles at the pod level or at the pod gravity level itself, and that is what is being mentioned in the case of IRSA, which is IAM roles for service accounts. So AWS has provided a native integration between the Kubernetes and IAM roles for such account, which is called as IRSA. That is what is being mentioned here. Um, And this is similar to what they said, that it is similar to what KIM and the Cube2 IAM would do. Um, but the implementation is completely different than what we have in the case of Cube2 IAM and KIM there, what is we mentioned there, right? Uh, So what happens, what I could get from here is AWS IAM supports federating identity out of the third-party OIDC provider, in this case of Kubernetes API server. Um, and it does with the help of pset. So what it's doing is it's a combination of your psets, which you saw earlier, and as well as the AWS IAM uh, roles there, what has been mentioned here. So as you can see here, it is the combination of the volume, what has been mentioned here, along with the IAM role, what is being given here. So as we combine both of these, we get this IRSA, what is there, and with that, the authentication can also happen. Abdul, are you there in the call?
Yes, yes, I'm there.
Yeah, Abdul, I think you mentioned that you have used it in production. Can you give some more input on this?
No, I guess what you said is pretty straightforward. Typically, what you do is you kind of connect with the OIDC that Amazon provides, and you just need to annotate your service accounts, right? Based on that, your pods get the access that the particular role that you've created in AWS IAM, right?
Hmm.
So that way you can give granular access to individual pods, and you don't need to rely on, let's say, node level IAM, or the other methods given here.
Hmm.
So I'm not sure what this YAML example here is. I've not used it this way.
Okay.
But you typically just need to add one annotation to your service account, saying that this particular service account will have access to a particular role in AWS, and you add the
AWS. Okay.
ARS, right? And whichever pod you assign that service account to will have access to the IAM,
Correct.
right?
Yeah, yeah. So this is like what has been mentioned here as well, that you are combining both PSAT and that, right? Yeah, Douglas,
Exactly.
go ahead.
Yeah, it's a very cool feature AKS. I am currently working more with Google Cloud, and GKE also has a very good workload identity.
Mhm.
I wrote a post in Portuguese on my blog a few months ago about this, and I think it's easier than AWS, the configuration.
Mhm. Okay. So there was that is yeah, I mean so it is not I mean as if I go by the book has not given all the details per se. So that is why I'm kind of not too confident in this at this particular point of time. But what I could get, what I think has been confirmed by Abdul as well, right? That you are somehow able to connect your service account with the AWS role, and if you connect them rightly, your workload would get the permission to perform um, whatever the operations on the AWS environment is. So that is at a high level what I could get from there. So in the yeah, yeah, go ahead, Abdul.
No, no, continue.
Yeah, on a similar note, I think one update was there from the recent AWS reInvent, right? They have said that there is now a better way to connect your pod with the AWS. Anybody followed that? I'll give you the link.
I think they got rid of the EKS auth config map thing. Not sure if they made major changes to this IRSA model.
Okay.
Yeah, so it's basically for authentication of users with the cluster, right? So when you run kubectl, uh,
Mm-hmm.
earlier you had to maintain a config map named EKS auth, if I'm not wrong, and there you kind of mapped the permissions that the users had. Uh, so for kubectl, you might want some users to have admin permission, some users to have read-only permission.
Okay, I just shared a link on the chat. See if anything else that makes sense. Yeah. Okay, fine. So now let's try to go next here. So the next part is to understand now is now assuming that I mean in the previous case we assumed that our entire setup is on AWS, right? And AWS can identify its nodes, right? Its workloads and all the things, right? But what if I am running in a environment where all the nodes are not from AWS, they are combined, we are running multi cluster and all those settings, right? And it may not be Kubernetes, it can be combination of different kind of machines, public cloud, private cloud, on-prem, whatever it is, right? So how do you now make sense of that particular environment, and how do you trust that this particular node is what it is saying it is, right? So for that purpose, we have this SPIFFE and SPIRE. So SPIFFE, if you look at the full form of this is Secure Production Identity Framework for Everyone. So this is the kind of the standard. So SPIFFE is the standard, and then the implementation of that is SPIRE. So again, it looks too complicated for sure, like the big name and all those things. But if you look at the concept wise, it's pretty straightforward, which I also kind of got to learn from this book. Um, so, so what is Spiffy is the what is the name is being given here, and then this is like a standard what they have come up with. So what happens with this is which will give you the SVID or SPIFFE variable SPIFFE verifiable identity document. So basically, once I implement this, I'm going to get an SVID which I can verify against the SVID server and then or SPV server and verify myself in a way. Correct? That is what is there, and Spire is the implementation of that. That is what you have to kind of take into account. Now there are two kind of attestation you can do. One for the nodes, and let me just get it. And second for your workloads, I believe. Yeah, let me just make sure that yeah, workload and then node, right? Yeah, correct. So as you can see here, we are going to have the Aspire server, and they're going to be an Aspire agent running on every machine. And through these agents, we can kind of generate our kind of a say node identity, and then similarly we can get for our workload as well. So what we are doing here is, if you look at, in this particular case, we are trying to generate the node identity by this command. And then, so if you look at here, what's happening here, let's follow the flow here. So you have the agent running on every machine. Then we have this particular attester running on every machine as well, as you can see here. Right now, what happens is the agent gathers the proof of identity from the underlying platform. So, for example, if you're running on AWS, you would have some whatever MAC ID or AWS ID, something like that, right? To identify you uniquely, right? And then this particular information is gathered, and after gathering the information, this agent sends the proof to the server, the Aspire server. The Aspire server will attach that with the plugin, whatever they may have, and then the server node verify the information. For example, this is your so this is in your middle of AWS per se. So this information is available with the AWS. This information is what agent is sending to the Aspire server. Now this server can validate with the help of what information is being sent and what is and the character by the AWS. So the Aspire server can of course get the request as well as it can validate by the AWS. And once this happens, you get your SVID. Basically, the node would get its own identity or SVID, so that it can then send this SVID to other nodes or other workloads, so that it can tell that, okay, I am verified by this Aspire server, something like that, right? That is what is happening here. And then similarly, what is happening, the next step is you are now doing with respect to the workload. Now for the workload, as you can see here, it is being done with the help of the underlying Linux, what you are running, the kubelet, what you have, and all those things. A similar thing would happen there as well, and then you again get an SVID for your workload, correct? And that is how the entire kind of a say the mesh would be created, and that is what we mentioned even later as well. So when you configure this service mesh, because every workload and the node is being attested by the Aspire server, once you put a service mesh like Istio in place, they can verify themselves or other workloads via this Aspire server, correct? So that way, basically, we can configure a secure or entirely identifiable environment within our environment, and that can, I think, go across the cluster as well, because this Aspire can, I think, expand not just into your one cluster. It can kind of expand more, right? So that is what Aspire and Spiffy is. So again, I'm not too expert in this, but this is what I could what I could get here. And then there are different what you call say your language bindings and other things are there. So for example, if you are running a workload and you want to identify your other workload, you can do that. So for example, this is the example what they have given here, that that example in Go, calling Kubernetes service B, and expecting the specific SPF ID. So when you are talking to the given endpoint, you can verify or you can check whether that endpoint has a given ID or not, correct? Because it's available in the mesh, and you can verify within the network or within the whatever the setup has been done with SPF and Aspire there. So, in a nutshell, if you can identify your entire workloads, your nodes and workloads with the granularity of each component, then you are sure that nobody else came from outside and perform any operation on my environment and so on. This is a very critical part, because you want to allow the communication happen only between the the nodes or the workloads you know about, right? So that is what this particular SPF Inspire solves it. Anybody has anything more to add here? And then it has supports for Vault, yeah, and AWS as well. Yeah, go ahead. Yeah,
I have a question.
yeah.
Inspire is something new for me. Can I use it on my YAW manager Kubernetes or just on AWS?
It can be used anywhere. It is a generic thing. So it is not meant
Okay.
only for Kubernetes. It's a generic thing. So that is what I know. Let me just try to, because it's a CNCF project only. Because I know that these things are hidden behind the regular people, right? Like us, right? In a way.
That's perfect. Thank you.
So you can definitely, I think, use it. So that is what I know. Yeah, yeah, Aspire. Yeah, it is. It is just like I'll just put the information here. It is definitely got a lot of traction, but things were hidden. That is why it was not basically kind of. It does not come very often in discussion per se. But you can read through it and understand more. Yeah, I think that's all from my side on this particular chapter. Um, So yeah, anybody want to add something? I know that this chapter was a bit challenging per se. I mean, at least some part of it's not too clear, and kind of there's some gray areas there at least. So I just try to do my best here to kind of understand myself and then try to kind of share it in a easier terms to others as well. But yeah, there may be some shortcomings here. So do let me know if there is anything which you think I missed it or I could do better here.
It's really good. Yeah. Thanks for leading this chapter.
Good, good, no worries. My pleasure. Okay, so there are two things to discuss. One is, of course, the next chapter. Waldemar, are you ready for the next chapter? You mentioned that you may want to do it.
No, unfortunately, I'm not. I have a meeting like half an hour before that starts that I have to be present, and maybe I can attend, but I can't be fully like engaged. So
Okay, okay.
unfortunately, maybe a next one
Hmm.
when I have for sure that I have a window there and I can somehow be present. Yeah,
Okay.
since the time shifted, a lot of meetings I have like overlap
Yeah,
with
I think
this
maybe
time.
once the time is back, right?
Time
The
is
daylight shaving
yeah,
is back, you can come back. Yeah, fine.
yeah.
Anybody else want to volunteer for the next chapter, which is going to be really interesting because this is what the next platform engineering is, I believe, right? So this is going to be the right base for the platform engineering, which is the hot topic in the industry now. Anybody want to take the lead? Okay, we can take a break also. What we thought, what discussed long back, right? So once we finish this 10 chapter, right, we may kind of try to build a quiz, right, around different chapters. The production readiness quiz kind of a thing, right? So we can experiment that on the next session maybe, and then maybe publish it for others to kind of come and give it a shot. So that is one activity which we thought of doing it, but if you guys are okay, we can, if you kind of volunteer or if you just want to say thumbs up, we can do that. So, sorry. Um, so the idea is basically we have finished 10 chapters, I think 8 or 9 more. How many of them are remaining? I don't know. Six of them are remaining.
There are 16 in total,
Yeah,
though
16,
6 are
16, yeah,
remaining.
six are remaining, right? So I think maybe in the next session, actually, right? If all of you can kind of, again, some people are new here, right? So what we can do is, if you are okay, right? Again, I'm just proposing it. I'm not uh, kind of putting it through completely. So the proposal is that we can kind of look at these 10 chapters, at least who have been part of the throughout of this, and we can build a quiz, kind of a say, right? And then anybody can host it anywhere. Basically, it's like we create a pool of questions, right? And then we make it public, and then let people try it out, and then check their knowledge of production level Kubernetes, what have we have learned so far, and then we can take this chapter, the platform on next week. Again, suggestion there. If you guys are okay, we can do that. Otherwise, we'll go with the book only. Any points? Any thoughts?
Yeah. And just give a thumbs up if you want a quiz. If not, we'll continue with the book club. Just give a thumbs up in the chat
Yeah, please. Yeah, thumbs up for what?
for the quiz.
Yeah. Okay.
There
Sure.
are
Sure.
no gifts or prizes, I guess.
Yeah. Yeah. Okay. Okay.
Okay,
So
I'll give
there are
my.
no. Yeah, so there are no. I mean, so out of I don't know how many people are there.
Yeah, I guess it's majority wins.
Majority wins. Yeah. So I think if there are no opposing, then yeah. Yeah. So yeah, fun. That's fine. What we'll do
How's
is, yeah. Go ahead.
how's the quiz? Is this gonna be like in the some Google Sheets, or
Yeah. Yeah. So what we can do?
are
Yeah.
we
Correct.
gonna
So
be
we.
live?
Yeah, so the way I was thinking is we can create a Google sheet. We can have a common, or we can just bring in our own questions in a way, right? Or maybe what we can do is like a play, right? Let's say we ask, or we can create a quiz ourselves and then give others to answer it, right? That is also a fun actually, right? So what we can do is, if all of you are comfortable, at least if we can have five people build the five different quizzes, right? You can have Google form, right, which can be a form of quiz, right? And you can bring up your own 10 questions and give others to answer. Let's see what happens.
Can we create a type form
Yeah,
Is it
whatever,
something?
whatever works.
so
Is
we
it
can
something we
conduct
share?
the?
Sorry.
Yeah, go ahead.
I was going to ask is to create those questions just ahead of time. We share them in the Slack or in the document that we have.
Yeah, yeah. So what we are saying is, all of us can create a quiz. So you
Oh,
create,
for
let's say,
us.
10 questions, and you publish
Okay.
them on Google Form, right? As a
Oh,
quiz
okay.
or type form. And then what we do is we share that link within this particular chat, and others can go and take the quiz and see how we perform.
Okay. It's a during the session or like during the
Yeah,
week
just do
before
a
that.
session only, correct. So basically, but you
Okay.
create the quiz beforehand, right?
Okay.
And once we give it, then we kind of discuss among ourselves that what is the right answer, wrong answer, and then there, yeah,
Okay.
yeah, it's a create a Slack, Francisco. It is there, right? So yeah, it's in the Google Doc what the Abdul has shared. Yeah. So let's go ahead. This will be fun. Yeah, go ahead. Arvind, you were saying something earlier. Typeform is
Uh,
perfectly fine.
I thought of like conducting a survey for the
Yeah, whatever
community.
works, whatever works. So basically, if you give me a link, if I can take that quiz, I'm okay. That's all it is.
Yeah, I will do that.
Yeah, so this is the first 10 chapters what we're targeting now. And then, of course, once these quiz are being done, you can publish them anywhere you would wish, under your name, under your company's name, whatever. Doesn't matter, right? But as a fun activity, we can do it in the group.
Yeah, okay,
Yeah.
thanks.
Cool. Sounds good. And then, of course, by the time if somebody else can take up the next chapter, think about, and then we can start the next chapter week after that. Yeah. So we still have one more week,
Yep.
one more week to
For the
think
next
about. Yeah.
chapter, I guess if somebody's not willing to, or like not ready to take the full ownership, I think one of us can kind of shadow you guys. That should not be an issue. So we can present it as a
Yeah.
team as well.
Yeah. That makes sense. Yes.
Yeah. So I guess we can finalize in the next session, right? Regarding
Yeah.
this. Okay.
Yeah. Sure. We can do that. Okay. Sounds good then. So next week is done. We'll all create the quizzes and share the link on the group. We'll take the quiz and then Yeah. Okay. See you guys next Sunday, and I think we'll have a lot of fun next week. Yeah. Okay.
Thank you
Okay.
so much, guys. See you next week.
Thank you. Bye.